Hello once again, welcome to my video. In this video we're going to be looking at the calculations involving the determination of the energy that is involved in a chemical reaction. So in this question reads as follows: a barium hydroxide solution that's BaOH2 aqueous reacts with nitric acid solution HNO3 according to the following balanced equation. So the equation is already balanced. So it's important that you take note of that the equation is already balanced. So the equation is BaOH2 plus 2HNO3 to give you your barium nitrate plus your 2H2O. The potential energy graph shown below shows the change in potential energy for this reaction. So you've got your potential energy in kilojoules per mole, and then it gives you the different sections, what's happening, A, B, C, different energies. So it's important that you take note of those and to be able to identify them. Even before you start answering the questions, you should be able to identify what is happening between each stage or at each stage. And then from there, you should be able to have an idea of what is happening. So this course of the reaction also is referred to as the extent of the reaction or the time of the reaction. So 7.1, is this reaction endothermic or exothermic? And you are to give a reason for the answer. When you look at the shape of the energy profile diagram that is given, you can see that, okay, from here it begins where the reaction begins. You've got your reactants, and where the energy content of the reactants is higher than the energy content of the products. So when you are looking at that, immediately you can tell that this is a reaction that shows an exothermic process, because if you were to calculate the delta HR, you would have a delta HR which is negative, showing that the energy content of the products is less than the energy content of the reactants. Therefore, in answering this, you would need to first of all state what it is, whether it's endo or exothermic reaction. You've got to give one answer. So the first answer that we're going to give, we're going to say that the process is exothermic. Why is it exothermic? That is the reason for the answer. It is exothermic because the reactants are at a higher energy than the products, or in other words, the reactants are or have higher energy than the product, or you could actually say that the products have lower energy than the reactant. Lower energy than the reactant. So any one of those is good enough to explain what happens, because at the end of the day, if you were to calculate the delta H for the reaction, it's going to be equal to H of product minus the H of reactant, and therefore that means when we do the calculation, you're going to get a value of delta H being less than 0. So you could actually even say as a reason that delta H is less than 0. And then the next part of the question, 7.2, use energy values A, B, and C indicated on the graph and write down an expression for each of the following. The energy of the activated complex. So the energy of the activated complex, it's the maximum, it's the highest point that the profile reaches. So this here is our activated complex. So you are supposed to tell us the energy value that this has. So in this particular case, it's going to be equal to A. So the energy value is A. And then the activation energy for the forward reaction. Activation energy for the forward reaction is the difference between the energy that the activated complex has and the reactants. So this EA is going to be our activation energy. So it's going to be the A value minus the value at B. So A minus B gives you the energy of the activation of that process. So A minus B, that is the thing. And then delta H for the reverse reaction. Delta H for the reverse reaction. So it is the energy that, so what is the reverse reaction? The reverse reaction will be starting from the products, going back to the reactants. So when we calculate the energy for the reverse, delta H for the reverse reaction, the reactants, which are initially the reactants, they will end up being the product. So you end up saying this value, the product, minus these would be the reactants in the reverse reaction. So it's going to be equal to B minus the value of that, which is C. And so that is the formula that you would use to calculate the enthalpy of reaction for the reverse reaction, right? So you could actually even say it's equal to minus 116, not minus but plus 116. So, but you don't know what you would be subtracting, so you use B minus C, and that's good enough. And then calculate the amount of energy released during the reaction if 0.18 moles of barium hydroxide reacts completely with the acid. So in this particular case, what you do observe is that delta H for the reaction, that is for the forward reaction, is equal to minus 116 kilojoules per mole, right? Minus 116 kJ per mole. However, you are now, that is per mole. However, in this particular case, you do not have 1 mole of energy that is going to be produced, right? Because you're not reacting 1 mole, but you're reacting a fraction of a mole. So therefore, the total amount of energy that's going to be produced is also going to be a fraction. We know that 1 mole of barium hydroxide, so we can actually put it this way, 1 mole of barium hydroxide produces your 116 kJ per mole, right? That's the 116 kilojoules. But now we don't have 1 mole, we have 0.18 moles. What is it going to produce? We don't know. So if you cross multiply, you would say, okay, X moles of the X moles, X times the number of moles of barium hydroxide is going to give you a fraction of that. So X, which is the amount of energy that's going to be produced by 0.18 moles, is going to be equal to 0.18 multiplied by 116 kJ. And then from there, it's going to, when you multiply that, put it into your calculator, it's going to be equal to 0.18 multiplied by 116. So the amount of energy that's going to be released is equal to minus 20.88 kilojoules, right? So this minus 20.88 kilojoules, it means 20.88 kilojoules are released. From the 0.18 moles of barium hydroxide that were used. Very simple, very straightforward. And yeah, if you like the video, please click like, subscribe to the channel, and share it amongst your friends. Thank you very much, and see you in the next video, where we are also going to show you another calculation involving the same thing. So you can always look for questions of this nature and you can practice, and it will be good for you.